this morning we get to talk about congruent triangles. So first off, what does it mean to be congruent? What do you mean the same? What do you mean equal to?
They equal the same.
What do you mean they equal the same? Yeah, so you're all right. When we say congruent, it's got the same shape and the same size. So they have the same shape and the same size. So in our congruent triangles, everything about each individual triangle is going to be the same. So what that tells us is it's the same for every single corresponding part. What does the word corresponding mean to y'all? Any ideas? Corresponding. When you hear corresponding, that would be complementary. It did. I like the use of vocabulary. That's okay. So we did have corresponding angles where they were both on the same side of the transversal, one on top, one on bottom. But what about just in English, the word corresponding? What do you think, when you hear corresponding, what do you think? What's that? Together? Okay, so when we're talking about this, if we have corresponding parts, which in congruent triangles we do, that means every corresponding angle and every corresponding side are congruent. So every angle is congruent to every side. Well, I'm sorry, every angle is congruent and every side is congruent. So if our two triangles are congruent, we can write a congruency statement. We can write a congruency statement. And that word's like, what on earth, coach? This guy right here, triangle ABC, is congruent to triangle DEF, is our congruency statement. In order for our statement to be valid, we're going to match all of the corresponding sides and all of the corresponding angles. Simply stated is, when we write it, we always write it by its angles, by its vertices. So A has a single hoop. In the triangle DEF, who has a single hoop? D. So what does that tell you guys? A is congruent to D. B has a double hoop. Who has a double hoop in the other one? E. So what does that tell you guys? B is congruent to E. And then lastly, C has our triple and F has our triple. So what's that tell us? C is congruent to F. So if we look at our congruency statement, ABC to DEF, our congruent angles are always going to be in the exact same spot. So A comes first. Because D is congruent to A, D comes first. B comes second. Because E is congruent to B, E comes second. And lastly, C comes third. And so because F is congruent to C, F comes third.
Wait, so the order that the statement is written matters?
It does. The order that our vertices are written in matters. Because if I don't give y'all a picture and I just give y'all that congruency statement, I know every single corresponding relationship that exists. I know all three angles and all three sides. All three relationships, that is. So our valid congruency statement must match all the corresponding angles and sides. This is a fun little one. CPCTC. What in the world is that? CPCTC. So the definition says if we know that two triangles are congruent, then we know each pair of corresponding parts are congruent. Now for this quiz, we're not going to use CPCTC that much. But on our test, we will, because we're going to have a whole day dedicated to this. So what it says is corresponding parts of congruent triangles. Oh, let me write the word congruent. Are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. And that's just simply saying what we were just talking about. If my triangles are congruent, then the 3 angle relationships and the 3 side relationships are also congruent. So let's list all the congruent angles and congruent sides given to us by our congruency statement. So they told me JKL is congruent to triangle PQR. So we've got 3 congruent angle relationships and 3 congruent side relationships. So we know because J is first, it is congruent to who? P. If J comes first, then it is congruent to angle P. If K comes second, then it's congruent to who? This thing is like slow today. It's going to crash soon, isn't it? If K comes second, it's congruent to who? Q. And maybe this thing will pop in there. There we go. And then lastly, L comes third, so it's congruent to R. Angle L is congruent to angle R. Now, sides gets a little bit more tricky without pictures, but we're going to remember that if my angle relationship is in order, what can we conclude about our side relationship? It's also in order. So what are the first 2 vertices in triangle JKL? JK. JK is one of the sides. Who would JK be congruent to in the second statement? PQ. JK is congruent to the segment PQ. KL is the second and third. Who would that one be congruent to? QR. How come? Because why? What's that? What do you mean it's opposite? So we're doing KL on the first one. Why QR on the second one? Anybody want to help him? But why? What's that? Sound like a muffled ninja. It's the last 2. If the last 2 in the first one, in order to be a true congruency statement, the last 2 in the first one must line up with the last 2 in the second one. This guy is running real slow today. He's not ready to be back from fall break yet. Okay, and lastly, this one's a little tricky. We're going to go the first and the third one. So JL. If we went first and third in the left, what are we going on the right? PR. Come on, you rascal. You could do LJ and PR, but generally speaking, The first triangle is in alphabetical order. And then the second triangle matches that.
Yeah, for sides, you put a little line above it.
For segments, we put the little line above it. Yep. So write another valid congruency statement. So like I just said, generally speaking, when we write our congruency statement, the first triangle is going to be in alphabetical order. But for the sake of just having fun, how can I rewrite our congruency statement? So jumble up the first one, triangle what? What do you got? Triangle L, J, K. Okay. So we're going to jumble up the first one, triangle LJK. Now, when we write our second one, we just need to make sure that the correct vertices in PQR line up. So who was L congruent to? L was congruent to Q? Why? Look at the angle relationships above it. Who was L congruent to? R. So L comes first. Now R is going to come first. What about J? P, and then K, Q. So we just rewrote our congruency statement, but we still have to make sure our vertices are lining up how they're supposed to. Let's look at number 3. Given triangle KPM is congruent to triangle AYC, complete the following statement. So just because it can help, let's go ahead and put our congruency marks. So K is going to be our single hoop. You know, hoop, there it is. Who would get the single hoop in AYC? Hey, how come? How come A gets the single hoop in AYC? It's the first one. Our corresponding angles are lined up perfectly for us. What about P? P gets our double hoop. Who gets the double hoop in the second one? Y. Good. And that leaves M to be our triple hoop and C to be our triple hoop. If we say, come on, man, catch up to me. KP gets our single tick mark in our KPM triangle. Who gets the single tick mark in our AYC triangle? What do you think? They will have ticks, but just like we have multiple hoops, we're just going to have multiple ticks. AY. How come? Why? Why are they congruent? Come on, thing. What do you mean they both have the same side? What? How do we know they're the same length? We're looking at our congruency statement. And if KP comes first, AY comes first. What about PM? PM gets our double. I really wish this thing would catch up before I drop kick it. It ain't cool. PM gets our double tick. Who gets our double tick in the right? YC. Oh, Peter. And then that leaves KM to be our triple tick and a C to be our triple tick. So yeah, just like we add a hoop to show a different relationship. What are you confused on? The fact that it's not showing up? I know.
Maybe we just shouldn't do notes today, Coach.
I don't think so. Yeah, you could relax. You had 4 days off.
Oh, yeah, the first fall weekend?
Yeah, what's wrong with that? It's all right. Let's see if we can. I could what? There we go.
We just wrote those?
That's what we're writing, yeah.
Does it matter which side you add more hoops on?
Does it matter which side? No, as long as the corresponding parts have the same number of hoops. Oh no, it's okay. The good old tricky internet's rolling with us this morning. It was on fall break too. It's got to catch up. I mean, it's still a break, son. All right.
More of a weekend.
Okay. I mean, I'll tell them to take it off next year if you like.
Yeah, that's cool. Take off.
Be like, the kids really don't think it's necessary. Let's just plow through it and keep going. Like, we don't need any breaks till Thanksgiving.
Yeah, we get a longer summer.
No. It's just a long weekend.
If we're taking away the break, maybe a longer summer.
No, brother, you just gotta accept it.
And they're like year-round guys.
Yeah, exactly.
Oh yeah, Mr. Burst about that like every day. And in America, yeah, he's like trying to go over there.
All right, what is KM? Who's KM congruent to? Hey, AC. Don't do that. Turn off. What about CY? Who is CY congruent to? MP, good. YA, or sorry, PK. Dang it, Sean. Angle Y. Who's got a double hoop? Double hoop. Hey, are you all right back there, son?
Oh yeah, I'm perfectly fine.
Okay. Angle K. Angle A.
Yeah.
Angle ACY. So ACY. So it starts at the single, goes to the triple, finishes at the double. So it starts at the single, goes to the double, right? Triple, it goes to the triple. Starts at A, goes to C, and then to Y. So single, triple, double. So start at single.
Then you go to Y, and then you go to C.
K and P. What about triangle MPK? CYA. And then what about triangle YAC? PKM. So it's just about matching up the corresponding pieces. So we can use our congruent features and they can hit us with some good old-fashioned algebra. What's wrong with you, son? We are. We do got to do it.
No, it's fine.
Okay.
Can we get Waffle House?
No. Not everybody got an A. What shirt? And I decided to come in topless. All right. So they gave us some numbers and our congruency statement. They said STW is congruent to BFN. So let's go ahead and match up the pieces we know. STW is congruent to BFN. TW is congruent to who? FN. Does FN have a value that TW doesn't? The value is 14. So if the SN's value is 14, what's TW's?
14.
Because they're congruent.
I couldn't have done it without Ethan, so thank you.
Okay.
Well, can I,
Yes.
if they're congruent, shouldn't N be, 82?
What do you mean?
Like, angle 82.
Angle 82 should be W. Does everybody agree with it?
Yes.
I do too. W is 82. B is 67. Does everybody agree with him? Yeah. But we're still missing that third angle.
No, we're not.
How, what do you mean we're not?
Now we can do algebra, coach.
We don't have to do real algebra yet, but we can do,
67 plus 82 equals, or plus x equals 180.
what do we call that?
Algebra.
What do we call it though?
Finding x.
Nope. It is something, some theorem.
Math.
It's not wrong. It's not wrong.
It's the
Jesus.
triangle sum theorem. The inside of our angles adds up to 180. Good job, dude.
227.
What?
Okay, yes, it's 30.
All right, so to find the measure of angle T, we're going to add our two known angles and set them equal to 180. What's wrong, bro? Okay. 82 plus 67 is what?
149.
149. After we combine like terms, what do y'all want to do now? Subtract. So subtract 149 from both sides. The measure of T is what?
31.
31.
Should be 31, coach.
31.
Oh, it could be something different.
It could have been, but y'all nailed it. Good job. So that if T is 31, what do we know about F?
It might be 31.
It's also 31. Because they're congruent. Do we know the measure of BF? 17. Where'd you get that from? Yep, it's congruent to TS, or ST. And then what about BN? What's the measure of BN?
Good.
Why?
You just started with that, dude.
Okay. What's the measure of BN?
Good.
Okay.
SW.
SW, which is 9. So we just did BN. It's 9 centimeters. So a lot of times people are like, well, coach, how do we know to put a number and how do we know to put another angle? What's the difference between A and the one from last time? An equal versus a congruence. And what does this segment not have on top? The little line. The little line's not there. What's the measure of TW? 14 centimeters. How about BF? 17 centimeters. Measure of angle W? 82 degrees. Sure, buddy. Measure of angle B? 67. And then measure of angle F? 31. Bueno. Yes. Muy bien. Good job. Let's look at our next congruent relationship. GHJ is congruent to XYZ. What kind of triangles do we got here?
Isosceles.
How do we know they're isosceles?
They got the same lines. They're congruent, guys.
Two congruent sides. Very nice. So if HG is 27, what's HJ?
27.
27. So what would X, Y, or YZ and YX be? 27. What about the measure of angle H? 38. The length of GJ? 18. But we're missing two angles. What do you mean no?
That's pretty easy, guys.
What do you mean it's easy?
Gotta find two angles that add up.
Find our X.
Hey, let me talk. I was talking first. What the bugger?
We can still find our XY. What do you mean?
What I do, coach? Okay, so you wanna know what I do?
I would love to know what you would do.
Okay, I take the 38 and I say, hey, I know a lot about 38. That it equals. And then, then I subtract, and then 38, I subtract 38 from 180.
And then you walk out.
And then I divide it by 2, and then I get both my angles.
Why?
Because.
What do you mean it's easy? What do we know about our two missing angles? They do not equal 180. What? Yes.
I got it right. I know I did.
Okay. But why?
Because I'm right.
But why?
Because I have knowledge.
Well, I didn't say that you did not. Why do you, what do we know about angle G and angle J?
I tried, okay, guys?
You did a great job. You have the right answer.
Your job is to do the math for me.
No, it's not. What do I know? What do I know about angle G and angle J? Why are they equal? Opposite sides are congruent, which means opposite angles are congruent. So what my man said back there is 100% true. He just set it up in his own brain, which is fine. I'm going to say that G and J are X. And then we're going to do exactly what he did to find the value of X. He said that those two angles, right, they are congruent.
You add them up, they're going to be the same thing,
So X plus X plus 38 equals 180. What you got, Chief?
Can Henry try to teach us the next one?
No, that's okay.
I can do it, I think.
All right.
I believe it.
I believe in him too, but minus 38, just like he said, you know a lot of stuff, dude. You're the man. That's all right. So, like he said, we're going to subtract 38 from 180. What's that give me? 71. 142. And then, like he said, we're just now going to divide that by 2.
That has to be 71. It's almost like somebody said it.
So X is 71. So that means each of our base angles is 71 degrees. Hey, we don't need no hostility. This is an everybody love everybody, peace, love, and happiness, baby. Let's roll. Okay. What does that tell me about X and Z? That they're also 71. Why are they equal? Why are they congruent? But why? But why? But what makes them congruent?
Because they equal the same thing.
But what makes them equal the same thing?
Because they're congruent.
What makes them congruent?
They equal the same.
But why do they equal the same?
Because they're congruent.
But what makes them congruent?
They equal the same.
Nope. X and Z are congruent because it's an isosceles triangle.
No, it's not that.
It is that. That's the exact reason. So what's the measure of GJ? 18 feet.
18 feet.
Thank you. What about XY?
18 feet.
Almost 27 feet.
Something like that.
Yep, somewhere in there. What about ZY? 27.
Are you going to think if we don't put feet next to it?
Sure. What about angle H? 38.
38. Oh, sure.
Angle Z?
71.
71. And angle J?
71.
71.
Shoot. That's shot by you. Thanks.
My man. So that's all fine and dandy when, you know, they kind of gave me everything I needed. But what happens if they throw a variable at us? We don't stop. We persevere. We dominate. All right, so they told me UVW is congruent to TSR. There is nothing we can do in these triangles with our angles. How come? They didn't give me anything about my angles. So on our quiz, we kept trying to do 180 degrees for sides when that doesn't exist. And then we tried to do a side relationship with our angles, but that doesn't exist. So all we can solve in 6 is something about our sides. How come? Right. So yeah, we don't know anything about the interior angles. We cannot guess. We cannot make a hypothesis. We can't make a conjecture. If they don't tell us, we cannot assume. So let's find our side lengths. They want us to find the measures of X, Y, and Z. So to do that, we're going to use our 3 side relationships. What are our 3 congruent segment relationships that we know? It gives us our congruency statement, yes, sir. So, well, if it gives us our congruency statement, we can detect our 3 congruent sides.
Oh, I know what we got to do.
What we got?
Okay, so, hold on. Let me fix my map.
That is so drippy.
I know, that's what I've been trying to say.
So, segment UV
It's like a hat. I mean, like 1830.
is congruent to who?
My old grandpa used to.
Who is UV congruent to?
No. What'd you say?
UV is congruent to who? TS.
TS.
And then, whoops, UW is congruent to who?
TR.
TR, very good. And then our third relationship we know is Volkswagen is congruent to
Yeah. SR. Oh.
So those are our 3 corresponding side relationships. Now let's see if when we substitute the values they give us, it allows us to solve some math. What's the value of UV they gave us? UV? TS is 53, I'll give you that. But we're trying to solve for x. So what does UV equal? Nope. 12x minus 7. Indubitably. So what do we got there now?
X equals 5.
Okay, but why?
Because 12 times 5 equals 60, 60 minus 7.
So what do you want to do first?
Find X just real quick.
How do I find x?
It's just simple math, coach.
Yeah, what is it though?
5.
But why?
Because 5 times 12 equals 60, and 60 minus 7.
Where'd you get 60 from?
I don't know, 12 times 5, you do not know these things, coach?
No, I have no idea.
Wait, hold on, not 60. Wait, what?
No. Yeah.
What would I do first here?
Listen, y'all gotta quit playing, and my brain is not.
What am I doing first, Kara?
Sure.
Add 7. We're going to add 7 to both sides. You know the rules for Waffle House, son.
Yeah.
Y'all know the rules.
I have a quick life hack for anybody who goes to Waffle House.
All right. Hey, save it till I'm done. Then you can talk about all you want. Just wait till I'm done, okay? Thank you. All right. And now what do you want to do, Henry?
Now you're doing it too complicated for me to understand.
What? You just told me to do it that way.
No, I did not. I just said you can easily know it by not solving it out. Therefore, it doesn't take as much brain power. Therefore, you don't get confused. You just do it quick. Exactly.
Didn't you do the same amount of brain power I did?
Wait, what was the last?
Nothing. Wait for it. Wait till we're done. Thank you. All right. What about UW? Who's UW congruent to? What's the value of UW? 3z plus 14 equals, what's TR? 50. Right. So what do we want to do first? Subtract 14 from both sides.
It's 12.
Okay. So 3z equals 36. What do you want to do next, Henry?
Choose.
Okay.
You want to divide it by 3.
Divide both sides by 3. So z equals 12. All right, and our last congruency statement relationship, VW is congruent to SR. What's the measure of VW? 57. What's the value of SR? 5y minus 33. What are we going to do first? Add 33 to both sides. $90? So 90 equals 5y. Divide both sides by 5. What do we get? What's wrong, brother? Oh. 18y. All right, one more, and then we can learn about the life hack. So this time they told me PHS is congruent to triangle CNF. Find the values of X, Y, and Z. What do we know is true now? What are we dealing with? Sides or angles? Angles. So what's our 3 angle relationships? P is congruent to who? So measure of P equals the measure of C. The measure of H equals the measure of N. And then lastly, the measure of S equals the measure of F. Now that we've discovered our three congruency statements, we can go ahead and solve for our missing variables, hopefully. It looks like they threw a curveball at us on one of them. Maybe not. What is the measure of P as it is given? P is congruent to who? Or what is P equal to? I'm sorry. 36. And what's C equal to?
36.
Almost. 4Z minus 32.
Yeah, I was pretty close.
I said you were close.
Sure.
Sure. Add 32 to both sides. So 30 plus 32 gives me 68. How am I going to get Z by itself? What's that? Divide both sides by 4. That's what I was telling you before. So what's the measure of Z? 17. Or the value of Z, sorry.
It's okay.
It's all right. It's going to be okay.
It's not really okay.
All right then. H. What's the value of H as it is given? Nope. 6x minus 29. And what's the value of N as it is given?
115.
115. Fly like a bird, fall far away. We're going to add 29 to both sides. 6x equals 144. Divide both sides by 6. X equals 24. Rolling right along.
Yeah.
What's the measure of S as it is given? It is given.
Nope.
It is, but just not directly to our faces.
3 minus 1.
So H was congruent to N, so we know that the actual measure of H is what?
Oh,
115.
hey.
So we know, yeah, they're tricky, them rascals. We know 2 out of our 3 angles. So what are we going to do to solve our third one? Triangle sum theorem. We're going to add them together and set them equal to 180. So the measure of angle S plus 36 plus 115 equals 180. Now, I probably won't do this to you guys as on level, but this is definitely something I would do to honors on a test. All right, angle F, what do we got? 36 plus 115? Can we just do that? No. 30 to 115 is, survey says, well, 151. We're going to subtract that 151 from both sides. So what's the measure of angle S?
29.
Measure of S is 29. Good. Now we can go back to our congruency statement. What did we just find out S to be? Almost.
29.
29.
That was a long time ago.
Okie doke. And then what would the measure of angle F be?
29.
But we're trying to find y, so what is the measure of F right now? 3y minus 1. What do you want to do first?
You gotta write it down.
I did. I did.
Add 1.
Add 1 to both sides. So 29 plus 1 gives us 30.
10.
What's 10? How'd you get 10?
Coach, I can't. Listen, Coach.
Divide both sides by 3. Okie dokie. I'm having fun.
I'm not.
Okay. You look like you're having fun.
Looking like something is not actually.
Well, I mean, I don't think you can fake that smile, son.